Good afternoon. Could you tell us your project title and each state your name?
Thank you. I am Vanessa Arias and our project title is Carbon Nanotube Carbon Monoxide Gas Sensor.
I'm Richardson. I'm an electrical engineering major. I did the technical production for this project.
I'm David Shin, also electrical engineering major, and I did the resistance analysis.
Nice to meet you all. Can you tell us a little bit about what your project is?
Derek.
All right. Basically, the idea is that it reads, we have a carbon nanotube sheet here inside our box. It's going to read the concentration of carbon monoxide in the immediate atmosphere. By principles like electron recombination, we can see a drop or rise in resistance of our sample, and by implementing that into a voltage divider circuit, we're able to find the voltage drop across a shunt resistor, do some analytics, and then zero in on a contour that tells us exactly what the concentration is, which then will trigger a certain alarm. And that's basically our project.
Can you tell us and show us a little bit more detail about your working prototype and how it works?
Okay, the working prototype with power applied, it will have this sensor like we were pointing out earlier. It's a glass sheet with tubes of carbon nanotubes going across it, and it has copper plating on each side, and it just kind of works like a resistor. And we have a visual and audible alert for the user. It would tell the user what danger area they are in, and there would be an audible alarm just in case there is visually impaired people using this device. And
that's it, basically. The gas
and the microcontroller.
Thank you. Is there something like this out in the market?
Good question. There are similar products like this. There's like an electrochemical, there's infrared, but what's the difference between our product and those products is that this carbon nanotube can be shrunk and miniaturized to even smaller sizes, and we foresee in the future, and we hope that we could have this put into cell phones or like tablets, so it'll be with the person wherever they go.
Okay, can you tell us how your prototype is better than what's out there in the market?
That's an easy question. The way it's better is that it's just smaller and it's not as bulky to carry around and have with you 24/7.
Thanks. How is this prototype different from the Senior Design 1 phase?
In Senior Design 1, we conducted most of our research and found, what the best circuit, best schematic, and way to actually put all this together. And we had all these different ideas of how to test it and things like that. In Senior Design 2, we started getting on all of our parts and putting it all together, and then learning by testing and actually using it how to revise and tweak our circuit and make it better. And we started learning all new things that actually affect the sample and ways to mitigate those effects. So basically, part 1, we had a certain expectation of certain contours and resistance and how it would work. And 2 is when we started putting it all together and then learning how it really is going to work. And that's when we did really most of our work, to put all of it together and do all of our analytics and everything and have a working prototype.
Great work. Do you foresee any future changes or possibilities for this project?
No, not really.
Anybody? Something you could be working on better?
Well, this is a new emerging.
Microprocessor, right?
Yeah, one thing we could do is do a PCB implementation, shrink it down further, and not have to rely on the computer for power. It would be a standalone device that would read out danger levels in the ppm. We could do even more testing with our balanced carbon monoxide gas that's balanced with nitrogen to give us different levels of concentration. Right now we have 50 ppm tank. Maybe we could get 100 ppm or 200 ppm and create different levels of alarms. That would be one great way to improve this. Another application for the material that we're working with is as a load cell, because it's really sensitive to strain and stress. That could be implemented into weighing devices on a really micro scale. It's got tons of possibilities. For our project, more quantization of this would be great.
Well, thank you very much for sharing today.
Thank you.
Thank you.
Good job.